Hi, and welcome to our lesson on radicals, adding and subtracting rational expressions, a more advanced look. First, let's talk some definitions. A radical expression, that means no equal sign, is an expression that includes a number, and it can also have a variable, a radical or root sign, and an index. So here is your expression, there's your index, and there's your square root sign. Adding or subtracting of radical expressions absolutely must be done with like terms. If you don't have like terms, you cannot add or subtract any of it. So let's take a look at an example. First of all, is 108 fully simplified? No. Is 56 fully simplified? No. And because there's no index written here, it's assumed to be 2, so we're looking for pairs. So let's break down 108 into prime numbers. We know that it's going to be 2 going into there, and it's going to be 54 times. 2 is prime, and I like to put a little dot underneath to keep track of my prime numbers. Now if we break 54, 2 can go into there 27 times. And then you can break 27 into 3 times 9. 3 is prime, and then 3 and 3. So if we're looking for pairs, we've got a pair of 3s and a pair of 2s. They both come out, they get multiplied together, and they turn into a 6 for the whole number on the outside. And then on the inside, we have that lonely little 3 all by himself. Now we're going to look at x cubed. X cubed simply means it's x times x times x. And if we're looking for pairs, out comes one pair, and we've got a lonely guy on the inside still. There's your lonely little leftover guy. And there's your x that was paired and gets out. Now let's look at 56. 56, we can have 2 go into 56. And let's see, it'll go in 28 times. 2 is prime, so we can stop there. And then it's 2 and 14, another prime number. And then 2 and 7, and those are both primes as well. Now, we're looking for pairs, so we have a pair of 2s, and then we have leftover guys that don't have a pair to them. So, we're going to add, we'll put it on the next line, we're going to add the 2 coming out because it's a pair, and then the 2 times 7 is 14. Now we have x to the cubed, which we've already done one time already. So, right up here, an x came out and an x stayed in. Alright, these are now fully reduced, fully simplified. The question is, are these like terms? It's all about what's going on underneath the radical sign. They're not like terms. You've got 3x and 14x. So it turns out that this would be your final answer because you can't add or subtract them because they're not like terms. But you can simplify them, which is what we did. Alright, let's take a look at the next one. Are these exactly the same? Yes, they are. Are they fully simplified? No, they're not. So let's break down 54, which is 6 times 9, and then it's 2 times 3, and 3 times 3. Alright, it looks like we've got all primes. And look though, this is cubic, so we're looking for cube roots, or groupings of 3. Well, I have 3 3s, so they can come out, and then I have a lonely 2. So he needs to stay inside the radical. And this is to the index of 3. Now we have y's as well. We've got 9 y's. So if we write out all of our y's, we have to look for groupings of 3. So we have 9 of them. Now let's see, I've got a group of 3, a group of 3, and another group of 3. I have 3 groups of y's. So that means that the exponent attached to it is 3, and there's nothing left over, so there's nothing to go underneath there. So right here, I fully simplified it. Now it says subtract a negative. 2 negatives collide, remember, they turn positive. So we're really adding. And here, it's the exact same as what we just did, so we know what it is. Except on the second part, you've got the 32 that you have to bring down and multiply it by the other one. 3y cubed, cube root 2. Here's the question. Are these like terms? They're both radical 2's, so we can go ahead and add the coefficients. But before you add them, look, you have to do some multiplication. So we have to do 32 times 3, which is going to be 96. So you really have 3y cubed. We've got cube root 2 plus 96y cubed. And then you have another cube root 2. All right. Now we did say that these were exactly like terms, so that means that we can do what it's asking, and it means to add these guys right here. They're like terms as well, so we can add them. We've got y cubed and y cubed. We have 3 of them, then we add 96 to it, so we've got 99 y cubed. Remember, when you add with exponents, they don't change, you just recopy. Then we've got our like terms of the cube root of 2. So this right here is going to be your final answer. You've got 99y cubed times the cube root of 2. It was a lot of work, but if you take your time, you'll be able to do it correctly. All right, let's look at the next page. We have a 64 and a 4. Those don't seem to match, but let's see if we broke down 64 all the way. 2 goes into there, and it goes into there 32 times. 2 is definitely prime. 32 is 2 times, it's 4 times 8. 4 is not prime, 2 times 2. 8 would be 4 times 2, and then another 4 is 2 times 2. So we've got a lot of primes here. But look, the index is 4, so that means we have to take them out in groups of 4. So we've got 1, 2, 3, 4. I've got a group of 4 2's, so they can come out as one whole group. And then I've got 2 leftover guys. So that means that, it's the 4th root, I have 2 leftovers, 2 times 2, and then I have m to the 10th. Because I haven't broken down m to the 10th at all yet. 2 times 2 is 4, 4m to the 10th, hey, that matches there. So that turns out that now I do have like terms. So I can go ahead and simplify the radicals if I can, and then subtract them like they're asking me to do. Now, 2 times 2 is 4, but that can't be simplified because there's no 4th root. However, we have 10 m's. We can definitely simplify that. So if I have 1, 2, 3, 4, 5, 6, 7, 8, 9, and then 10, and I'm looking for groups of 4. 1, 2, 3, 4. I got one group. 2, 3, 4. I have 2 groups, and 2 guys are left over. So that means 2 groupings of the m's can come out. So you'd have 2m squared tells you there were 2 groups of them. 4th index, then you have 4m, 2 left over. And you're going to take away 1/2. And again, 2 groups of m's. And then the 4th root of 4, and 2 more m's are left over. These are exactly like terms here, and these are like terms here as well. So we can go ahead and do what they ask us to do, and that's take 2 and subtract 1/2. So if you have 2 minus 1/2, that's 1.5 or 1.5. Remember, when you add or subtract with exponents, they don't change, they just get recopied. And then we don't change our like terms here either. So this would be our final answer. It wasn't too bad. Now, we did have one more, and that's this one right here. So 24 is 2 times 12, 2 times 6, and 2 times 3. Since there's no index, it's assumed to be a 2, so we're looking for pairs. We have a pair of 2's. So the negative drops down, 2 comes out, and what's left over is 6z to the 16th, and I haven't broken that 16 down yet, but I'm going to add the 3m, 5z to the 6th. Now, the problem is that I have a 6z and a 5z, so I know that these aren't like terms, but I can't stop yet because I know I can also break down the 16 and the 6z a little bit further, and then I can stop. So if I have 16 z's and we're looking for pairs, how many pairs are in 16? 16 divided by 2 is 8. So you actually have 8 pairs of z's. And that 6 is still there. Because you had all of the z's pair up, you don't have any left over under the radical. Now, we're adding 3m. I have 6 z's. How many pairs of those are there? So 6 divided by 2. I've got 3 pairs. I still have the 5 because it won't come out, and I don't have any z's left over. So here's where I have to stop. This is not like terms, and this is z to the 8th, and this is mz to the 3rd. None of those are like terms, so that's as far as we can go. You can't add or subtract it. That would be your final answer. All right, let's look at a quick review now. When adding or subtracting rational expressions, only combine like terms. Keep the whole numbers outside of the radical when you're adding or subtracting them. The index does not change when you're combining like terms. When we combine them when they're to the 4th root, the index stayed to the 4th root. And be sure to simplify any of the remaining radicands. And that's it for our lesson on radicals, adding and subtracting rational expressions, a more advanced look.